Welcome to Math 63, Unit 2, Lecture 1. This is Part 2, Rules for Simplifying Expressions. Let's get started. A number of years ago, when I was teaching in England, I was asked this question. I started teaching algebra to some 6th graders, and I was, writing, something like, 5x plus 3, and wanting to talk about, okay, what are the different possibilities of things that this could be and all that sort of thing. And what ended up happening is this young 6th grader got really agitated and put his hand up and said, Sir, what is X? And what the confusion was up to that point, they had been solving for x. So if you had 5x plus 3 is equal to 8, for example, and then they had been figuring out, oh, okay, x is equal to 1. We'll get to why that is later. Okay, they would get here, and this was good, but this is wasn't what I was talking about. I was trying to approach algebra from kind of a higher abstract level, which is what we're going to do right now. Okay, but I want to make it clear that while x is an unknown quantity, that doesn't always mean that we're going to approach it like something that we need to know what its value is. Okay, as we go on, especially when we get into graphing, you'll see that there will be times where x can take on a whole bunch of values, and it won't really matter to us what specific value x takes. So let's just set that aside for the moment, and let's focus on, rather than what is x, let's just focus on what can x do. All right, so if I had x, this is the symbol that I'm going to be using. Well, what things can I do with x? Well, this is math, so I'm hoping that I should be able to add it. So what could I add it to? Well, I could add it to a constant, so I could have something like x plus 1. Okay, that's somewhat interesting perhaps. Can I do anything to that? Not really, right? Because x, as I said, x is an unknown, we don't know what it is, and 1 is a constant, so there's, we can add them together, and we've done it. We've just written it down. Okay, cool. What else can I do to x? Well, I could try adding x to itself. Sure, okay, so then I could add x plus x. And what would that be? Well, x plus x is going to be 2 x's, right? That's how that'll work. So we can add x to itself. But in doing this is making it clear that there's something we can do when it comes to constants and x. We could use some multiplication. So I could say 5 times x, and that will just be written as 5x. And for multiplication, we're not going to put any symbols in when it's clear that we're talking about multiplication. Okay, so when we have a number and a variable, we mean multiplication. Okay, so we could do multiplication. I'm just pointing out, 5x we know is x plus x plus x plus x plus x, but we could also, do something stranger like 3.5 times x, right? Which is just 3.5x. We could do something like that, and it's not quite the same as saying, hey, we have x plus x and then a bit. I mean, that is what's going on, but it's not a simple repeated addition when we're doing multiplication by scalars like that. Okay, cool. So we can multiply by scalars, we can add x to itself. What else could we do? Well, we've got all of the rules of addition and multiplication. So let's talk about what are the rules of addition and multiplication. So let's bring in another variable. Let's talk about x, y, and z. Okay, if I'm adding numbers, I could talk about x plus y, and I know that x plus y will be equal to y plus x, no matter what numbers I put in for x and y, right? This is called commutativity. Okay? So I use this word, this isn't a word that you have to memorize or anything like that, but I use this word a lot to remind people, oh, it doesn't matter what order we do the adding in. Okay, so we've got commutativity for addition, and there's also commutativity. So if I do x, y, that's equal to yx when I'm talking about multiplication. We've got commutativity for multiplication. Now notice that if I had subtraction, x minus y is not the same as y minus x. Not at all, right? So in this case, right, if I had, like, let's take a look, 3 minus 1, that does not equal 1 minus 3. On this side, I have 2, and on this side, I have negative 2. They are not the same. Okay? So subtraction is not commutative. Same goes for division. If I have x divided by y, that does not equal y divided by x for similar reasons, right? So if I had, let's say, 3 divided by 1, that doesn't equal 1 divided by 3. 3 divided by 1 is 3, which is not the same as 1/3, right? Obviously. Okay, cool. So commutativity, it works for addition, it works for multiplication, but it doesn't work for subtraction and division. Well, hang on a moment. Let's just a quick reminder, though. I'm going to put it right here. Just a quick reminder, though. If I had subtraction, let's say this 3 minus 1, I'm going to rewrite this as 3 plus negative 1. So now I've rewritten this into addition, and I do have commutativity. Okay, so addition is nice in this way. Same with 3 divided by 1. You know what, this is a bad example. Let's try 1 divided by 3. 1 divided by 3. Okay, we could, rather than using division, we could turn this into a multiplication, and you remember this from our fractions. Take this fraction, which is 3 over 1, and reciprocate it into 1/3. 1 times 1/3 is 1/3. Okay, and that works. But just as well as 1/3 times 1, right? We could just as easily switch the order there. Okay, cool. So we have multiplication and addition are commutative, subtraction and division aren't. Okay, so there's another rule called associativity. If I have 3 numbers that are being added together, x plus y plus z, it doesn't matter what order we do the adding. I could go x plus y and then add the z, or I could say add the y and the z, and then add the x. And either way, we would get the same answer. Okay, and you can try this with any set of numbers. This works for addition, and it also works for multiplication. So xy times z is equal to x times yz, like that. Okay, so the result here is that we can write down things like x plus y plus z and x, y, z without any confusion at all. People understand what I mean when I say this, right? When I say x plus y plus z, we don't have to say, oh, do you want me to add these two first or add these two first? It doesn't matter. Okay, so this is called associativity. Okay, so this property is a property of addition and multiplication. Now, it isn't a property of subtraction or division either, and you can check that. Check, if I had, let's say, 5 minus 2 minus 3, right, if I do it this way, that is not the same thing as 5 minus 2 minus 3. Okay, so not so good. But, of course, with 5 minus 2 minus 3, I could rewrite that as 5 plus negative 2 plus -3, and we're golden again. We can be associative. Same goes with division and multiplication. All right? Cool, so that's associativity. So those are the two big rules that we're going to be using that are specific to addition and multiplication. How do addition and multiplication work together? We have the distributive law is what you've probably heard. So distributivity. Distributivity. There we go. So distributivity. If I had, say, x times y plus z in brackets like this, hopefully you remember, or you've seen this before, I can then say this will be equal to xy plus, xy plus x times z. Okay, so this rule here is called the distributivity law, or this distributive rule. And if you read it one way, we're talking about distributing the variable x to both parts of this sum. If you read it the other way, we're talking about common factoring. Okay, we won't be doing much factoring in this course, but just as a reminder that that's a thing that exists out there. Okay, cool. So those are some important rules when it comes to algebra.